Good morning, everybody. We're on page 437, lesson 106, more on systems of three equations. Now, we've dealt with these before, so they just get a little bit more complicated each time. So 2x plus 3y equals negative 4. You notice I left a little space because it's missing the z. And I left space here because it's missing the y. And here I leave the space for the x because it's missing the x. And I'm looking back to make sure that I copied this correctly because I sure don't want to have a sign error or anything else in here before I start working this. All right, so before, what we had to do was we had to eliminate one variable two different ways. So let's see here. I only have to eliminate one variable one way in this case because for example, if I work with these two equations right here and I get rid of the x's, then I'll just have y's and z's, which is fine because if I work with these two and get rid of the x's, then I only have y's and z's, which is exactly what I have in this one. So then we'll be able to use substitution or elimination. There's no rule that says I have to work with the first two or the second two. I could work with the outside ones. I can get rid of one variable any way I want to. So let's see, what would be the best way to do this? Let's see. I think it would just be easier to multiply this one by a negative 2. So help me out here. That would give us negative 2x, and this will become positive 4z equals negative 2 times negative 3 is positive 6. And now if I just copy this one right underneath it, so 2x plus 3y equals negative 4. Now we add these two together, what happens to the x's? Well, they cancel. That was the whole idea. So now I have 3y plus 4z is equal to 2. All right, so that's one of my equations. And here's 2y minus z equals negative 6. That's my other equation. So now we have two equations in the same variable, so we can either use substitution or elimination, whichever you want. Personally, I see this negative z and this positive 4z. I'm just going to multiply this equation by a positive 4. So that gives me 8y minus 4z equals negative 24. Adding those together, I lose this. This becomes negative 22, and 3 and 8 is 11y. So we divide both sides by 11, and we get y is equal to negative 2. Now once we have one of them, we just start plugging them back in until we get the other ones. So this right here looks like a pretty simple equation to plug into. This would be 2 times negative 2 minus z is equal to negative 6. Or negative 4 minus z is equal to negative 6. And I can add z and add 6. So I get z is equal to positive 2. Now I can take one of those either place, and all I have left to find is x. So I'll just use this top equation again. 2x plus 3 times y, which is negative 2, equals negative 4. So 2x minus 6 equals negative 4. Add 6. 2x equals 2. So divide both sides by 2, and x is equal to 1. So if you want to write this as an ordered triplet, you can. I don't insist on it, but please make sure you put them in alphabetical order if you do. X is first, y is second, and z is third. Okay, don't make a mistake of writing them in the wrong order as a triplet. Just leave them like this. It's fine with me. There's y, and there's x, and there's z. That's fine with me. You don't have to put it in this form. All right, let's try another one. On page 438, we have 3y minus 2z equals negative 12, and 2x minus 3z equals negative 5, and x minus 2y equals 6. All right, you guys look at that for a minute and figure out which variable you think that you would like to get rid of in which two equations. Okay, maybe you pick something different than me. The easiest way that I see is to multiply this one by a negative 2. So this will become minus 2x plus 4y equals negative 12. And then I'll take this one down here. It's 2x minus 3z equals negative 5. So adding those together, that drops out. We have 4y minus 3z equals negative 17. So now I have one that has y's and z's and another one that has y's and z's. Now, there's no super simple way to do this. I for sure wouldn't use substitution, but I don't know. Smaller numbers would be multiply this by 3 and multiply this one by negative 2. So from the top equation, we'll get 9y minus 6z equals negative 36. And from this equation, we'll get minus 8y plus 6z equals positive 34. And so that drops out. 9 minus 8 is 1y equals negative 2. Okay, well, I'm just going to take it right here because that one pops out at me. So x minus 2 times negative 2 equals 6. X plus 4 equals 6. So x equals 2. And now we need the z. How about this one? 2 times 2 minus 3z equals negative 5. 4 minus 3z equals negative 5. And then I'm going to subtract 4 from both sides. So that'll be minus 3z equals minus 9. Divide both sides by negative 3. Z equals 3. So as an ordered triplet, we have x is 2, y is negative 2, and z is 3. So the most challenging part of these problems is figuring out which variable you want to eliminate first and which two equations you want to use. Once you have that figured out, you've got it down to substitution and elimination with two variables and two equations. It's not difficult at all. When you copy these down, guys, always write it like this, to where you're leaving the spaces for the variable that's missing. If you don't, you're never going to be able to figure it out. It just becomes way too confusing if you try to write them the way they're written in the book. So always rewrite them with the spaces left for the variable that's missing. All right, thank you very much. We have a test scheduled for Friday, and you'll get more information on that when we get closer that time.